The astronomical object of May 2025 is M101, one of the most beautiful galaxies out there. Welcome back to Boring Astronomy. I'm Alessandro, your astronomer next door.
Boring astronomy.
In case you're wondering, I'm Alessandro. I have been in astronomy for the past 20 years, and I'm here to share with you some of the things that I've learned along my way. So to begin with, let's try to locate M101 in the sky. Where is it? So for this exercise, we're going to use Stellarium, which we've been using in other occasions for these kind of videos. And we're going to locate in Vatican City, which you may or may not have heard, has been through a lot of interesting news lately. For the new Pope, let's locate for him M101. So this is the sky at night over Vatican City. So we look for M101, which is a galaxy, and there it is, very much passing at meridian. And you can easily find it if I switch on the constellations. This is basically the pair, and this star here is actually 4 stars, or 6 stars. It's a very funny system. At some point we may speak about this. And just next to it you can see M101, and if we zoom in, well, we see Starlink bothering us, but you can keep zooming in, and at some point we start recognizing its beautiful spiral structure, and this is the reason why it's one of the most photographed objects in the sky. The new Pope is a mathematician, so we cannot just stick to how pretty this galaxy is. So let's try to give some numbers. So we come to our good friend Stellarium, and we search here for M101, and it says that it's a galaxy in a pair of galaxies. We will think about the pair in another video, so this time we only focus on this galaxy. We're in May, and we see that the coordinates are 14 hours, so that makes sense. The declination is 54 degrees, which tells us that it's very well visible from the northern hemisphere. Sorry, people from the southern hemisphere, you're going to miss out. And we get the redshift. This doesn't give us the distance. We can check the distance. Let's check the distance right away. For extragalactic objects, you want to check the NASA Extragalactic Database, or NED. And again, we put here M1, and again we get the image, we get the coordinates, we get the classification. Yes, it's a galaxy, it's an AP, blah blah blah. And among the other informations, we have the distances. And the distance in megaparsecs is about 6.5, and here we get the distance modulus, which is something that we may make a video about. But let's go back to Simbad. And this is a function that is very little commented about Simbad. On the right hand side you have this small image, which in this case is from the Sloan Digital Sky Survey. So you can open it, see it in all its beauty, you can move it around. But the interesting thing is that you can go back and say, instead of SDSS, I want to see how this galaxy looks like with XMM. And now you have the XMM image of it, and you can see that there is a clear X-ray emission from the center. There's other X-ray emissions from the rest of the galaxy. They're probably ultraluminous X-ray sources, and you can check all-wise, which is which is near infrared, But the most interesting thing is, if you see again the image in SDSS, and now we go to Galaxy, now you only see the spiral structure. That is because the spiral structure is mostly dominated by very high mass stars. So these are stars which are very massive, they're very hot, and they are very, very bright in the ultraviolet, in the blue if you prefer. So these are the spiral arms, and that is where most of the star formation is happening. And it's very much like what happens in the Milky Way, and the sun is actually in one of the arms of the Milky Way. This is almost as if you were looking at the Milky Way from above. And in that case, the sun would be, roughly where this red spot is. I didn't do it on purpose. Now, among the hot stars, there's one specific type of hot star which is interesting to us, and is the Cepheid kind of star. These are stars which are named after the progenitor, Delta Cepheid, and this was the star that Henrietta Leavitt in the 1920s, literally 100 years ago, discovered that they can be used as distance indicators. In other words, the period of their light curve gives you an indication of the average brightness. This is a work that several people have been doing, and in particular I want to emphasize the work done by Ben Shappy and Chris Stanek, and let's hope I manage to open this article. So what Ben and Chris did was they used the Hubble Space Telescope. They took several images of several fields in M101. These are the images, but what we care for is this part here. So here they show the light curves and the derived periods. They fit the light curves, and by fitting the light curves, they derive a distance. They also compare with another method, and they eventually derive a distance of, what we said before, about 6.5 megaparsecs. Why is it so interesting? It became so interesting because in 2011, a Type 1a supernova exploded in M101. And Type 1a supernovae are the result of the explosion of a white dwarf in a closed binary system, where the white dwarf is approaching the Chandrasekhar limit and therefore is disintegrated. This is the kind of objects that people have been using to determine the expansion of the universe. Rees, Perlmutter, and Schmidt have been awarded the Nobel Prize for. So in 2011, there was this Type 1a supernova which exploded, so we could make a very good comparison between a very well-sampled light curve and very well-studied supernova with all the other methods that we use for distance determination, and we could even try to study the progenitor of this supernova. So far, the studies on the progenitors have not been particularly successful, but the galaxy is so close that we actually could go and check if it was that star or that star which exploded. The problem is the star must have been very, very faint, so normally there's a lot of confusion for us. Interestingly enough, there was another supernova which exploded 2 years ago, and we've been following it up, including myself. And but it was a Type 2 supernova, so no relation with distance determination, but it was a spectacular object nevertheless. So what is your favorite aspect of M101? What is some aspect of curiosity that you would like to know? And what are your favorite objects for the sky of May? I'll talk to you soon. Ciao.